Good evening. I hope we're all fine. All right, so today we will be doing what we've done so far in research methods here online. So quickly, I want us to go through the slides and then appreciate some stuff before we start the main business. Otherwise, sometimes because some people are not really reading the slides, when some jargons are being mentioned in class, we don't really understand. So let's quickly go through the slides and then appreciate them. Then from then we will jump on to Excel and then come to SPSS. So kudos to our facilitator, Dr. Abekusam Edu. And today, okay, let's go through this. All right. So this session, so we are now coming research methods data analysis session. So this session seeks to explain the difference between categorical and numerical data, distinguish among nominal, ordinal, interval, and ratio scale of measurement, and provide example for each. So we can also read chapter 1 to 3 of Anderson, whatever. So data and scale of measurement. Data is a collection of observation. That's basically what it is. Data is a raw fact, just collection of observation or on process information or something like that. So data can be numbers, text, audio, visual, pictures, and etc. General classification of data. We can classify data into qualitative and quantitative, right? So qualitative more seeks of words, right? Where quantitative is more about figures like numbers. You get it? All right. So so here quantitative will be text and then qualitative. A qualitative will be text and quantitative will be numbers. So data can also be either categorical or numerical. We'll talk about this very soon. So conversion of data for research outcome, decision making purpose. So we are going to convert data to information, to knowledge, and then to wisdom. So categorical data. A data is categorical if observation in it can be grouped into categories, right? So an observation is from a set of non-overlapping categories. Selecting a bad category can mess the research. So research outcome. Two levels of measurement exist under categorical. So when the data for a variable consists of labels or names used to identify an attribute of the element, the scale of measurement is considered as nominal. So you get it. If the data for a variable consists of labels or names, right, used to identify an attribute of an element, so let's say gender, names, or the scale of measurements is considered as a nominal. There is no intrinsic order. So nominal data example, I don't really even need to explain because so nominal data examples, we have employment status, marital status, gender. We can also gender. So more or less like, let's say good or bad, something like so, things that have like two possible outcomes. So in a data set, males could be coded as 0, where females can be also coded as 1. So in what we'll be going to do, we'll be using 0 for males and 1 for females. Keep this in mind. Here, the scale of measurement is still nominal, even though the data appear as numeric value, right? in a data set, males could be coded as 0, female as 1. Here, the scale of measurement is still nominal, even though the data appear numeric. Why? Marital status could be coded as D if divorced and M if married, single, S if single, and W if widowed. You get it? Order is useless. So even though we can represent them by numerical values, it is still nominal. So the second part of categorical data, the first time we spoke about categorical data being nominal, which nominal normally have, like, let's say 2 possible outcomes or so, because gender can be either female or male, right? The bi and those people, no, I don't know where they are from. Sorry. They'll tell me that I'm discriminating or I'm being discriminating. So gender can either be male or female, and then marital status can be either be single or married. Employment status can be either be unemployed or employed, and the like. So the measurement scale, we are now under ordinal. The measurement scale for a data is ordinal if the data exhibits the properties of nominal data and the order or rank or rating of the data is meaningful. Ranking could be done in ascending or descending order. So, for example, a data is categorical and ordinal when it has, like, some skill. Let's say you are predicting, you have a suggestion that, let's say, on a scale of 1 to 10, Mahama will become a president. Well, let's say 1 will be strongly disagree, 2 will be disagree, 3 will be neutral. So 3 will be neutral, 4 will be agree, and then 5 will be strongly agree. Something like this. That's where the data is categorical but ordinal. So it's more or less like you having a skill of weighing something, right? So let's say you can also be like that most people like research methods, right? So 1 can be, let's say, agree, like, and the like, disagree, strongly agree, and the like. So here, ranking could be done in ascending or descending order. So you can either use strongly agree as 5 or strongly agree as 1. Any of them doesn't really matter. That's what they are trying to say here. And so, ordinary example, your class rank can be coded. Excellence, okay, so excellence can be like the same way excellence is A here, and good is, no, very good is, I think, B plus, and then good is B and the rest. So you can do the same, so you can code the same thing here, right? Such response to questions coded from a scale of 1 to 5 as strongly dislike, neutral, like, and strongly like the same way as strongly agree, disagree. Here, what does the rating of 5 indicate? So now let's come and talk about numerical data. So numerical data, a variable is an interval scale if the data have all the properties of ordinal data and the interval between values is expressed in terms of a fixed unit of measure. So scores on an interval scale can be added and subtracted but cannot be meaningfully multiplied or divided. Always numeric. So these are self-explanatory, and we have interval data examples. So between a temperature of 100 degrees and 90 degrees is the same as the difference between 90 and 80. So 3 students with start math score of, let's say, 620, 550, and 470 can be ranked or ordered in terms of best performance to poor performance, right? So this can be best, normal performance and then worst performance, something like that. So numeric data in the ratio side. A data is ratio if the values or observation belonging to it may take on any value within a finite or infinite interval. They are numeric variable with absolute, non-arbitrary. So 0. You can count, order, and measure. So ratio data examples include income, amount of sugar in an orange, number of employees, age, distance, height, weight, time needed to run a mile, and etc. So these are the levels of measurement. All right. So we have nominal. Attributes only named, like attributes are only named, which is the weakest. Then ordinal, attributes can be ordered. Interval, distance is meaningful, and then ratio, absolute 0. You try that. So the same thing here again. So ratio data and interval data are quantitative, whilst ordinal data and nominal data are also what qualitative, because they are more of categories and the like. So now you can also take this exercise as yourself. So short exercise, myself data. So it doesn't take from a level 400. Not a question, and that's a solid size response. So you can also do this of your so age of respondent. Is age of respondent and a nominal categorical data, or an ordinal categorical data, or a numeric data? So you can see age is a numeric data, right? Professional qualification can be a categorical ordinal data, because it will range. You get it? And then what's your monthly income? This is also numeric. So these are all self-explanatory. And okay, so section 2, researchers. So analyzing data. Researchers' choice based on methodology. Research approach versus research strategy. Research approach, quantitative approach. So research survey versus. Okay. So basically, these are what we are going to do today. These are what we are going to do. One sample t-test, independent. Yeah, so far we've done, I think, one sample t-test. Okay, we'll go there. I think, yeah. So we've done one sample. We've done independent samples too. Yeah, so these are the two we've done so far. We've not done ANOVA and the rest. So I think whenever I get the info or I'm being taught, I'll come and then share. As you already know that I hardly keep information, so I make sure that it reaches everyone. So now these are what is really important, because this was normally mentioned in class, and then people were like, hey, what is it? What is that? So now let's do Univariate data analysis, which is UDA. This provides quantitative data exploration. So it analyzes single variable of interest, like age. If age, you get it. If income, you get it. So tools for UDA, we use descriptive statistics, which measures the mean and standard deviation and the like. And then sample t-test, which is dependent test. We also use one-way ANOVA test, single factor, histogram distribution of continuous variable, box plots for detecting and removing outliers, and etc. And then now we have bivariate. 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 Is it variate? Yeah, bivariate. Yeah, sorry. So this provides analysis for two variables. Right? Two variables. Keep this in mind. It can come in exam. Two variables to explain the association. Right. So attributes, means of groups. Tools to consider for bivariate data analysis includes correlation, linear regression, independent sample test, as we'll be doing in this video, two-way ANOVA, scatter plots, and the rest. So now you remember we first did univariate, univariate, which is 1, bivariate, which is 2. Now we are on multivariate data analysis. Multivariate data analysis provides analysis for more than 2 variables to explain the possible association or causality. Causality, sorry, this is causality. Provides deeper insights and more accurate predictions, enhancing decision-making in data-driven industries. Tools to consider for multivariate data analysis. So multiple regression, MANOVA, right? And MANOVA, MANOVA, conjoint analysis, factor analysis, structure, equation, and the like. So hypothesis testing. So whether in our personal conversations, business life, or academic research, we usually make a tentative assumption about the whole, but making a statement in one thing. Making a statement is one thing. Testing the authenticity is also another thing, right? We can say something, right? But testing it is another thing. So this session examines the tools needed to hypothesize and conclude with given samples. Remember, we did hypothesis in quantitative method. So if you really took it very serious, this shouldn't be a very tough nut for you to crack. This is because here is the case. We are no more normally calculating always, but it's more or less like we are now coming to use machine or PC to calculate for those who were using calculators like normal hands and mechanical stuff to calculate. So reading lists are here. So what is hypothesis? Hypothesis is a statement, a claim or assumption about a population parameter, such as the average, variance, standard deviation, and etc. So it is more or less like an assumption about a population. So a hypothesis can be a statement or a question. Like, let's say income has a positive effect on consumption, right? So meaning that we are maybe in this study, for example, we are coming to check whether income really have effect on consumption, positive effect on consumption. So here it can be that, let's say, an increase in income has positive effect, or an decrease in income. Remember, even in economics, for example, when the good is a normal good, right? When your income increase, you buy more, and when your income is down, you buy less, right? But same way, when it is an inferior good, when your income is down, you rather buy more, and then when your income is more, you rather buy less, and the vice versa. So they are socially responsible for firms. Are socially responsible firms or more profitable? Are socially responsible firms more profitable? So to test hypothesis, we first bring out our claim or talk about the null hypothesis and then the alternative hypothesis. remember that according to our coordinator, he said when writing this in exams, we should make sure that we write it well, and then when trying to state your null hypothesis, it should be HO, not H0, right? So null hypothesis HO, then you bring your semicolon. Is it column? Yes, column. Yes. You bring it, and then your mean will come. The population mean. You say we cannot get the same thing, so it is U. So let's say we are assuming that every household has at least three TV sets, right? As using the last semester slides, for example. So, for example, initially the HO or the the null hypothesis assume that your claim is true. So at least three, right? And then your HA will be HA. He said it can either be capital or small, any of them. And then, so in exams, if they give you and then they tell you to say the null and alternative hypothesis, so HA. So now this one will be U is less than 3, because the alternative hypothesis is completely opposite from the null hypothesis. And then mind you that he said this figure, let me see this figure, this sign which is greater than or equal to, we will not be able to get that on the keyboard. So it should be this sign and then the backslash, which is on the keyboard, which when you press shift and then I think question mark, yeah, shift and then question mark, you get it. So you press shift and question mark, you get this backslash. So if it is this two, you press equal to, you get equal to, and then the backslash. If it is these two, you get this, and then the backslash. You get it. So, okay, I think when, wait, okay, I think it will be like this. So this two and the backslash, yes, because this will always come first before the backslash will follow. This will always come first before the backslash, and the equal to it will always come first before the backslash. So that's what we are going to use in here. So we are going to use the T statistics, critical value, and then the P value, level of significance, and then statistically practical significance. So remember the T-test statistic formula, right? Which is the mean difference over the standard error, which the mean difference is sample mean minus population mean all over sample standard deviation and like this, right? So X bar or sample mean minus population mean is the mean difference, and then what is down here is the standard error. The S over root N is the standard error. Remember, N is the number of, or the sample size, sorry. N is the sample size. So I think we will do more of it. So the null hypothesis is a statement about a population parameter that will be assumed to be true during the conduct of the hypothesis. So always we assume that the null hypothesis is true. That's what that's the issue at hand right now. So we want to do a test to see whether it is true or it is not true. That's when the alternative hypothesis comes in, right? So the null hypothesis is either rejected or accepted based on the sample data. Remember, Dr. Abeku said that in the exams, we shouldn't write accept. So if we are rejecting the null hypothesis, we should just type reject. Reject. Right? And then if we fail to or if we are accepting the null hypothesis, then we should just write fail, meaning that we fail to reject. So when we are rejecting, we write reject. But when we are accepting the null hypothesis, we fail to reject. So we just write fail there, and then when it is reject, write only reject. Then that's what we are going to type in there. Keep this in mind. So for example, the average number of TV sets in a typical Ghanaian home is at least 3. So at least 3 basically mean that at least 3, meaning that if we go inside any Ghanaian home, if we don't even see any TV, not at least 3. So from 3 and above. That's why the null hypothesis is saying that U is greater than or equal to 3. So the null hypothesis said the assumption numerical to be tested. The test is always about the population parameter, not about a sample statistics. You get it? So even though we take a sample to test whether the population null hypothesis is true, our focus is not about the sample that we're taking, but we are just only trying to use the sample to judge whatever is in the population, right? Begin with the assumption that the null hypothesis is true, similar to the notion of innocence until proven guilty. So it refers to the status quo. Always contains equal to, greater than or equal to, or less than or equal to 9. May or may not be accepted. For example, the alternative hypothesis will be for this one. I've said this already. And then with that one too, it will never contain equal to, less than or equal to, or greater than or equal to. It will contain not equal to. Not equal to, it will be containing this one. It will be containing this ones, and then this one. This is the straight thing for alternative hypothesis, right? All right. So let's move on. So it's generally the hypothesis that is believed or needs to be supported by the researcher. So this is what the researcher is actually working on. That's basically what it means. So like the packaging division or whatsoever. So they want to find whether they are failing it according to 5K target. So U is now hypothesis is the mean is 50. That's so they will take samples to check whether it is sorry, the mean is 5. So they will take samples to check whether it is 5 or it is not 5. As what it means to me, the same thing. Same thing. So errors in making decisions. This all we explained. I think I've explained this already, but let me go to different types. Different samples would give different values. Therefore, results based on samples could technically give different results, quite different from the population mean. Basically, what this means is that when you select a sample and then the sample gives you an information, yes, sometimes it can be true. You can get the same prediction, right, when using the population, but sometimes it will change. For example, the null hypothesis about the population could be true, but due to using results from a sample, it could be rejected. Likewise, the alternative hypothesis could be rejected, although true. In such cases, we say the researcher has committed an error. So we have type 1 error, rejecting a true null hypothesis. So when a true null hypothesis is being rejected, so an example could be like, let's say, in an exam where you've written the correct thing and they've marked you wrong, right? That is like a type 1 testing and it is considered a serious type of error. When you are marked wrong and then you see that, you quickly go to the lecture to go and change it. You get it? So it is the same as a serious. We have type 2 error is when we fail to reject a false hypothesis, right? Meaning that we feel like more or less that the alternative hypothesis is true, but we fail to recognize that it is true. And that one is the type 2 error. So basically, it is the same, using the same example as the exams, right? If let's say you've written a wrong thing and the lecture mark is correct, remember you won't go back. You won't go back for the lecture to change it. You get it? So that's the type 2 error. So it's more or less like you've written something wrong and the lecture have marked it correct, type 2 error. But you've written something correct and the lecture have marked you wrong, is type 1 error. Let's move on. So this is the same thing. And the level of significance. The level of significance is the probability of making a type 1 error when the null hypothesis is true as an equality. It defines rejection region of the sampling distribution, and it is designated by alpha. Is the level of significance. Typical values are 0.01, which is 1%, 0.05, which is 5%, and then 0.1. But in Legon, we normally use 0.05, which is 5%. So it is selected by the researcher at the beginning, provides the critical values of the best of the test. Sorry. So this is the level of rejections and stuff. So if your alpha false, you see where we've shaded here is the rejection zone. So if your alpha falls within here, for example, if it is a lower tail, and the alpha falls within here and lower, this is 20, the same thing. I don't need to even. So this is more or less like normally the rejection zone is normally based on the alternative. So if the alternative is less than, then it will come to the left hand side or the lower tail. If the alternative is greater than, then it will come to the right hand side or the upper tail. But if it is not equal to, then we divide into 2. So mean that alpha will be divided into 2. So if it is 5% significant level, it will be divided into 2, meaning that 5% divided into 2.5%. That's basically. So basically what this means is that when you get an alpha, right, which, for example, for lower tail, if you get an alpha which is lower, right, or equal to what you've gotten, like let's say if the alpha is, if you saw for the C and you had let's say 4 point something, you're going to check on the distribution table, right, and you had something, and then your alpha is lower than 8, right, then you reject the null hypothesis, right? You reject, meaning that it is within the alternative. But if but if it is greater than it, right? If it is greater, so here is negative figures. So if you get a positive figure, you are not rejecting, you are accepting. You get it? So basically the same thing to here. If you get an alpha which is greater than whatever you solve for, then you are rejecting. If it is in the shaded region, you are rejecting. And then you will talk about the two-tail test when you solve and then it is within the two sides too, you are rejecting. But if it is between where it is unshaded, you are not rejected. So steps in testing hypothesis. You write your null hypothesis and alternative hypothesis. So you compute the test statistics. That is the calculated value. Find the critical value. That is the tabulated value from the table using the degrees of freedom. Find the p-value using the calculated. Compare the, I can, if you are really interested in doing this, you can text me, then I will send you a video I recorded last semester for this particular stuff. So these are what we can test. So for means, we can use single sample, large or size. So when it is large, greater than 30, we use the z-test. If it is less, we use t-test and the likes. So data analysis with SPSS. We can do one sample test, two sample tests, third sample test, analysis of variance, ANOVA, which is ANOVA regression modeling. So this is how it is, lower tail. When it is, this is for one population. So we can press something. Yeah, one population independent, so meaning that they are two, right? It is one population, but they are two distinct. That's why U1 is greater than U2. It is the sample mean 1 is greater than the population mean 1 is greater than population mean 2. And then the alternative is U1 is less than. Same thing as what we did last semester. So T computed, which is this, right? Which the numerator is the mean difference, which is the sample mean and the population mean. And then the downside, the denominator is the standard error, which is the standard deviation over the root of n, right? The same thing is here. Using age distribution of undergraduates, collect data from a respondent in the class, average responded in the class, estimate an average age for the undergraduate students in the class, develop the research hypothesis, use single sample or T test to reject or fail to reject the null hypothesis, provide a conclusion of your research on age distribution. So we are going to do this very soon. Needs to population. Right, so we didn't do paired sample. So going through. All right, so the same thing. So now we collected our data. This was the data we collected. We clear this guy. All right. So now we can. All right. So now these are the data we've collected so far, and we collected it from 31 students, right? From 31 students, and these are the males, the females, and then their ages, and then so far we didn't collect only age, we collected their World Cup predictions, and then monthly allowances, and then we will do this later in this chapter. So what we did was we collected these, right? For the World Cup, for example, we were predicting whether Ghana will win the World Cup or not win the World Cup. So on the scale of 1 to 5, if you choose 5, just strongly agree. If you choose 4, agree. If you choose 3, neutral. If you choose 2, disagree. And then when you choose 1, strongly disagree. So that's what we are seeing here, and then we are going to that. So first of all, let's do for the descriptive. You can use Excel to do descriptive statistics, even though our chapter is not really concerned about it, but I think it was taught in class, so let's try that one. So what we are coming to do is that we will go to data. We'll go to data. You see data analysis. Some people do not have data analysis, so you have to install. If you want to install data analysis, you come to file, yeah, and then you come to options. You come to option, you will see add-ins. Come to add-ins. Click. After clicking on add-ins, you come to go. Then you will see this as I've already selected. You will see that analysis 2 part is in. You take it, right? You take, let it become blue or green or so. Okay, I can't see this color. Well, I can't blend it. Oh yeah, blue. Then you press, you click on OK. Then it will be installed. You see when it comes to data, you see it here. Right, you see it here. Sometimes I prefer to move it to I prefer to move it to the quick access toolbar, which is here. So it will be here so that when you are using it, you wouldn't really. So now let's use the descriptive analysis on this, right? So now we come to data analysis. Then there will be a whole lot of analysis tools here. So we are going to select descriptive analysis and descriptive statistics. Select descriptive statistics. You can either double click. Let me go back. When you can either double click or you just highlight it. Just highlight it. Then you click OK, or you can double click on it. So you let me highlight and click OK. Right. So now they're asking you for the input range. So you can choose to select from age up to the end and then add labels in first row, or you can choose to select only from the 22 up to the end and then you will not choose labels, right? So let's choose from the age and then we choose all of them. You click and then drop. You get it. So you click, you drag. That's why I say you drag up to the last one. So at the input range, you are seeing it here, right? Then because you selected the age to be passed, you are clicking label, right? And then our input range, we want it on this same, we want it on a different way, so we are putting it somewhere here. Okay, let me put it at, right? Oh, sorry. So input range, let's select the input range again. I did a mistake too. We select the input range again. Like all. Then output. Since we've selected the output range, come and then click the output range box. And select, let's say J2 or something or any of them. Then make sure you click on summary statistics. Right, confidence level is already 95. And we click OK. So this is what we are seeing here. Double click the edges and then it will expand it for you. See. All right, so we can see here that according to the information or the age that we are having, our mean age is 21, and then our standard error is 0.23. Median, mode, and the likes are all here. The count here is the sample size. The sum is the total sum of the ages. The range is the difference between the maximum and then the minimum. So the maximum age, which is 24, and then the minimum age, which is 19, is that one. For the ketosis and then the skewness, less was spoken about. Then the standard deviation is also here. We know that standard deviation divided by the samples, the root of the sample size will give us standard error. Right? Let's do this. Remember that. Remember this. Remember this, right? This formula. C is equal to x bar minus u all over it. The x bar is the sample mean, right? All over s over root n, right? We can do this same thing. So far what we are going to do that, let's assume that u, this is the population mean. Let's assume that it is, let's say, 23. So we are assuming that the population mean is 23, right? So let's do this. Let's do this. So now let's solve for the mean difference, which is the x bar minus x, right? All right, sometimes. First of all, let's solve for the standard error, which is the standard error, for example, which is this one, is the standard deviation divided, so equal to the standard deviation figure divided by square root, which is squared. Not squared that you know, please. Not that one. It is squared. It is square root that they've shortened it like that. So you double click and then you click count. Enter. Oh, yeah. Close it for me. So you see what we are getting, 0.23489. This is the same as this. Just that this one they've run it. That's why we are getting this. So you see, we are getting it here. So you are seeing that, right? So now, if we want to find our t, then what we are going to do is that we are going to equal to, this is the sample mean, right? Minus, which is x bar, right? Minus the population mean is 23, right? Population mean that we've assumed is 23. We are getting negative 2. So now remember it is x bar minus u all over the standard error. We've calculated the standard error here, which was the standard deviation divided by the root of n, the square root of n, sorry. So we've done that one. So what we are going to do, if we want c test, it's equal to this divided by this. And then this is what we are going to trace on the table to find our alpha, our p-value. You get it? So this is basically it. So if in case you are given, you are told to find the standard error when you are giving this info, right? When they tell you to find the standard error, maybe they will remove this one too. They will remove this one, and then they will tell you to find the standard error. Remember, the standard error is this sample size, the count divided by, sorry, it is this standard deviation divided by the root, the square root of n. That's what we are seeing here, square root of n. Same thing, right? So since we are done with this, we also did other stuff too, but that is not examinable. That's not really the case. So I don't know. I'm contemplating whether I should do it or, because we tried using the pivot table to draw do bar chart. Let me try and see. So what we did was what we did was what we did was come to, let me see, then insert, yes, it comes to insert. I'm pronouncing it insert. Come to insert, come to pivot table, right? Then you take the range that you want to select for the pivot table, like for it to control the pivot table. Right, so you want it to do it from this side. Right, so we want to use only gender. So let's put it in a new worksheet, right? Let's put it in a new worksheet. So I put it in a new worksheet. So once you put it in a new worksheet like this, it will come here. So once it's come here, we come to pivot chart. Right, there are bar charts and the rest there, but we are not going to do that now. What we are going to do now is we are going to bring this down here, and also we can bring this down here, and then we can also bring this down here. Then we change this with left click, choose value data, value field settings, sorry. Okay, then it will count for you, but since we don't really want to, let's pull the back. This is what we have here. So now, pivot chart, you can now select bar chart. Come back to pivot chart to select bar chart. It's in the columnar form. We select, let's say, this one. Then, okay. Now we have our data in here. Right, so meaning that those who are 19 years are 2. Those who are 20 years are around 10, 11. Those who are 21 is 8, 22. So we are seeing this here. Then we click, you can left click or right click, then and left click, come to format data series. You right click, come to format data series, then you come to okay, first you can change this gap because there are spaces within it. Maybe you didn't like it, you come to close gap. So now you see how it has become now. You come to fill and line. You click on fill. You choose vary colors by point, so it will change the colors for you, right? Then we come to effects. You can choose 3D effect. Then you choose the first one. You can change to any 3D effect you want, whether this, any of them that you want. So if you like this one, for example, this is what we use in class, right? Then you are done for this. So you can copy this to your Word document and then start working with it there. Sorry. So let's right click on it again. Left click, then right click, right? Then come to the add data labels. Come to add data. When you won't click on it too. Well, once you right click and then you come to data, add data labels. Don't click anything. Just leave your pointer on it and then to bring this stuff, and then you click add data callout, and you see that they will tell you the age 20, they are this, and then they are that, and then they are this. So you can also add this one here. When you add gender, now you see it is telling you that male, female, and the likes, right? So now you are getting only this. You get it. So you can take this and then something like this. So female is 16, male is 14. You can do a whole lot with this. You get it. You can do a whole lot with this. So let me bring my age in here. Let me send my gender back. And then let me copy this. Let me copy this whole thing. Copy. You right click. You copy. You come to your Word. Then you start your research. You are doing your research. Right. You write something. Then come down. Then you paste. You are seeing it here. Control plus V will paste, or either Control plus V will paste, or you can right click and then click on paste. Then you are seeing it here. Then you can reduce the size and write about this that based on the statistics. 20 people, there are 10 people in the class who are 20 years, and they are this, and they are this, and they are that. Get it? So that's basically at that side. So let's continue on our Excel. So that's it up to this, but there's no really, I don't know whether this is examinable though, but let's move on to our analysis, our data that we collected. Now, these are the data that we collected. We are coming to transport all these data to SPSS right now, but we have to change the gender, right? Being male and female. Remember, we said in the slides that we are coming to code them to code male to 0 and then female to 1. We are coming to do the same thing here. So let's kickstart. So now click on gender, right? Then you right click. You can either click on gender and then you right click and then come to filter. Sorry, come to source, right? Or you click on the gender, then you click on, let me see whether it's page layout. Yes. So you click on gender. You click on gender. Then you come to data. What's happening? All right, you click on data, then you click on filter, right? You see this signs will come here. These signs will come on top here, right? So now we want to change male to 0 and then female to 1. So you click on the arrow sign pointed down here, right? And left click, you get this. Then now we want to select, we want to change male first. So we only pick male in this. So we untick the female, which is the F, and we select only the male. Okay, right? We click OK. Then now we come and then type here. So we want to assume that male is 0, right? So you click on the first this and then you press 0 on your keyboard, right? So when you are done, bring the pointer to this side. You see that there is this black this thing here, right? You can either double click or drag and drop. So when you drag up to the last one, it will change to 0. Or you can choose to just click it just at the last end like this. When you see, then you double click to change everything to 0 for you. Right, so now we are done changing M to 0. Then now we come and select only F now. Sorry. We are done changing M to 0. We click the same thing here again. F. Okay. Now we want to make F1. So kindly do this for me. You click on this space 1. You can either double click or drag or click and drag. So double click, everything will change to 1. Or you can click and then drag to the last one. Change successfully. Now you go back there again, then select all now. Then everything will be back. So 0 is male, this is female, and the likes, right? So now let's go to SPS. We are going to transport this to SPSS right now. We come to SPSS. So if you open your SPSS, this is how it will show. Blank like this, nothing is here. We have data view and a variable view, right? So we are coming to put everything at the variable view side, and then it will appear at the data view side. So now we are coming to show this side. So we are coming to select, do everything. So here is gender, right? So gender. Remember, here only accept words, not sentences. You can't write indicate your gender or something like that. So it is only words that are accepted. But if you want to put your word in the form of sentences, then you have to bring underscore. So gender type you can. So if it is then you do gender type. You get it. So you see that immediately you start this session and you come to data view. It's here. So you can either do a gender or gender type, anything like that. Remember, gender type is not numeric. We have to change this. So if you want to change, you see this, check this inside here. You right click, then come and choose strange. And okay. Then label. Now this is where we will type. Maybe during the research, it will be like indicate your gender type. Indicate your gender. Here you can type sentences. All right, wait. I think there's something here that. So he taught us of how to do Google Forms. Let's do the Google Forms first. So basically, Google Forms helps us to compile data in an easy form as compared to you printing questionnaires and the data. Google Form will make everything an Excel form for you. So once you get it, and then you come straight to you download it, it will bring you straight to Excel. So now Google Form, for example, you can either open your Google Chrome and then use the right by you there. Let me just go, just type, let's say google.com here. Type google.com here. Right. Now you are going to see this thing here. Click on it. You are seeing everything here, right? So when you scroll down, you see forms. Click on it. Now you are coming to create a new form, or there are templates there which will make it easier for you, right? Click on, if you want to create a new one, click on blank. Now the title of your form. So now you put your research name there. Let's say the name of what's your research title. So life after SHS. It's life after uni. It's difficult. It's difficult. Okay, becomes the impact of laptops on academic performance. Right? Then you come and then write your description, nothing, why you are taking this type of research. So you are researching to see whether a laptop has an impact on academic performance. So something. So now you come and then type your question that maybe indicates your name. Okay, no. What is your name? Simple name, right? Then short answer, right? Then when you are done, you click add. Then the next part will come. Indicate gender. Then option 1 is male, and then option 2 is female. You get it, which is here. Then when you are done, indicate here, let's say level of education. So here can be SHS, university, graduate, and the like. So this is what you are going to do when you are done university. Right? When you are done, then what you are going to do now is you are going to click send. Right? So send means you are going to send this to people for them to fill for you. So you click here, come here, then click. You see the link here, but this link sometimes looks long for people. You can shorten it. Right? You shorten it, then now you copy. When you send it to someone, then the person clicks on the link. I'm just pasting the link here. So when the person clicks on the link, it will open this for the person. So the person will type name, fearfully ugly, and then I'm a male. Then submit. Right, it has been selected. It has been filled. So when you come back here, you see responses here. You see that fearfully ugly has responded to your questionnaire. So fearfully ugly has responded to your questionnaire. You have also the statistics here. See, very clean and nice. If you can transport it straight to Excel, I create a new thing. So you see the time that the thing was filled is here, the name, everything is here. Are you seeing it? So easy and fresh and clean. Simple. You get it? So this is the power of Google Form. All you need to do is to have a Gmail account and you can do this. So now let's go back to our SPSS. So now we indicated gender type. Here was numeric. We changed it to string. We leave the rest here. We leave rate and decimal. Now the label here is indicate your gender type. Like it's here you can type in there. Then now we come to values. So here we are assigning values to what you've done. Remember that in our Excel we assign values to them, which we change F to 0, M to 0, and then F to 1. So we come here and then we click on this. Then we click 0 was M. The value you type 0, label it was M. Click add. Then 0 again. Now you click 1 because it's sorry. Now 1. Then click F. Right, because 1 is F and then this thing 0 is M, so you add. Okay. Right. Here we leave everything same way as it is. We leave everything. Then now here. Remember, what did we say about categorical distance? This is just a true distance, a true outcome. So it is what? A nominal. But if it has like let's say a scale of let's say 1 to 5 or something like that, then now one we change it to what? Ordinal. So this is nominal. We leave it like this. Now let's look at the other one, which is age. So now let's go to age. Now age, come here, age. Right. Let's change age is numeric, so we leave it like that. And remember, these decimals, when they are discrete, when they are discrete, it is 0. But when it is continuous, we can leave it in the decimal place that has been requested. So still it is 0. Because then indicate your age. Right. So now we leave here because this is about age. We leave it, we leave everything. Remember, age is a numeric distance, so the measure of it is scale. So we check that one and then we change it to scale. And then now the next one is word cap. Let's type that one to here. Word cap. Sorry, you see, because I added 6, I didn't use underscore. So you see, variable name contains an illegal character. So world underscore cap. You see, nothing is happening. Remember, this is, we are now coming to predict the word cap, and it is not numeric. It is an still. So we change this one to string. Okay. And then now Ghana will win the World Cup. Right. So now we are come to assign values to them. Remember, it was between 1 to 5. So 1 would be disagree. A will be strongly disagree. We add 2 will be agree. We add 3 will be neutral. We add 8. Then I'm also. We add 4. Sorry, I'll do some correction. 4 will be agree. Add 5 will be strongly agree. Right. Remember, 2 is supposed to be disagree, so we change it to disagree. Right. let me see. All right, so this doesn't change because I didn't really. All right, click change. Right, we are here. Now remember that the measurement for this thing, that is scaling. Let me say that is it. That is more or less like like predictions. For example, it's an ordinal. It's ordinal. Change that one to ordinal. Let's see what we have again. Have monthly allowance here. Okay. So monthly underscore allowance. Remember, this was numeric. This is numeric, so we leave it numeric. Here we change it to 0. Monthly, your monthly allowance. So remember, it is based on say because we collected data about it. That's why we are writing it here. Then it is we leave here none. Remember, a numeric this thing is having a scale, right? This is what we have in here. So now let's see here. Let's see what we are having here. You see, all what we've done here is appearing at the data view. We've coded everything here. All right, let's just enlarge it so that enlarge. Let's enlarge. Right. So now we are going to bring whatever we've done in Excel here. Let's go to Excel. We did up to monthly allowance. So let's copy. Here it's not part because it entered the gender, the age, and everything there already. So we don't need to copy add them in this. So just click here and let's copy all here. So you see, I left the gender, age, and World Cup, and then monthly allowance out. So I copied only the figures. So copy that here. Control plus C. I copy. Right, I move to SPS. Then I click on this first side. Right, I click on this first side and Control plus V. Everything has been pasted. Just remember that here, for example, in Excel was 0. It was just number 0, 1, whatever. But when we came here, it changed to M, F, and whatever. And here too, it was 3, 5, whatever, 4, whatever, which was the predictions was 6, right? They've all changed to agreed because we've coded everything, right? You can choose to maintain them by coming here, value labels, and then changing it. When you click on it, it will turn to the numbers again, right? But if you want to change it, you come to there, you come there, and then you click on it, and everything will change. You see how nice it's in here. You get it, right? So now let's move on. So now you see, you remember the remember this, right? This bar chart that we did here, we can do the same thing in there by coming to analyze, coming to descriptive frequency. Then we choose we use age for that, right? So we choose indicate age. You come to indicate age, and then you click here to push it here, and you click on chart. We want a bar chart because the other one was a bar chart. Now we click continue. Let me see something like this. Okay, here you can choose to choose. Okay, let's choose the panel. Okay, let's take it. Only in the bar chart now. So click. Okay. Now this side to open it. To give you a bar chart very soon. It is running frequencies down here. You can see running frequencies. A bar chart will come very soon. Hurry up, hurry up. Where is the bar chart? Now, here is it. And then, remember the bar chart, where 20 was 11 and the likes, the same thing to reaching the same thing here. We can do the same editing to in here by click on it. You tap on your mouse, which is selected, you left click on it, right? Double click to open a pop-up for you, right? This is a pop-up for a very distance, so you can type a new name for this. If you can't type the text. All right, so you can click on this, just right click on it and then double click to open another page for you. Then you come to fill and border, right? And you click fill and border, you can change the colors. Let me just choose only one of them. Right? I'm choosing only this. I've clicked on this, double click, come to change this one's color. But you see that in Excel gives us varying colors, so it automatically changes. But this one you're going to do it one, so I will change this. Yeah, let me do that. Yes, it's only this. It will be that only this has changed. If you also still click this and then double click, you right click first and you left click first before now you double click to open. It also open a page for you like this now. If you want to change this onto this color, apply. I want to change. You see how it is. So you can do same for all of them. You right click, you left click, then now you double click, it will open for you. So you see that when you left click, a certain line falls or a shadow falls on it. You can see some thin line in here, and a click thin line. So this one too, when you are done, for example, when you are done, right, you can also copy this, click on it, Control plus C, and then you go to Microsoft Word, your Microsoft Word. Where is it? Where is my Word? Where is my Word? So you can also paste it here. You can also paste it here. You can see this one is also here. Control plus C, paste it here. Okay. You have it in. So you can use the same thing for analysis. But this is not really the thing. Now let's go to the real deal. So the real deal is now we are coming to also do this statistics here. So now, like what we did here, like what we did in this Excel, what we did in Excel here, this one. What we did here, for example, we are coming to do the same thing, SPSS. When we come to analyze, when we come to descriptive statistics, frequency, right? We did it for age. So age is already here, right? Let me bring it back. Now age is already here. All right, it's here. So we click here, bring it in here. Now we come to statistics. Choose here. Here we pick all of them. Of course, we need them for explanations. We click on sum, median, mean, on premium. Then now we come to charts. Now we want a histogram, not a bar chart. A histogram. We want to show our normal curve to see whether it is normally distributed or not normally distributed. So normal system continue later. So now we see that it will be processed very soon. Here is it. This is it. So this is our histogram. This shows that this thing is normally distributed, right? It is normally distributed. So if this was to move here, if this normal curve was to come around this side, it will be like if it were to come around here, yeah, like this, and we will say that it's skewed to the left. And if it were to come here, and we will say that it's skewed to the right and the light. So it's basically so this is basically the same thing. You remember, mean was 21 in Excel here too. And let's come to Excel. Then let's go. Let's come to Excel. You can see that mean is 21 here. Let's see standard error. Standard error is 0.235. It has been run. So let's go to Excel. 0.2348. So the same as 235. The same thing. Standard deviation 1.287. And deviation 1.2865. So 67. The same thing. The same thing, right? So this is what we just did. But now, what is our interest? Now we want to use this information that we have in here to run a hypothesis, right? So we are come to run a hypothesis that where is the we are come to run a hypothesis that the mean population in level 300 research methods class is, let's say, 22. The population mean is, let's say, 22. Okay, no, I use 23. So we are come to run that it is 23, right? So since it's 23, so we are assuming that the mean population is 23. So the mean population is 23. So H0 says that it is true. So the null hypothesis is that you bring your column, then you population mean is equal to 23. Then alternative is saying that no, what you are saying is false. HA is saying that you population is not equal to 23. So we are come to test this using SPSS, right? They will give you the distance that tells the population that is what is the now an alternative hypothesis. So you are supposed to write this and that. Since it's they brought it to mean that it is absolute, right? If they say at least, then it is different. By when they say if, then you bring equal to sign. At least it's greater than or equal to, and at most it's less than or equal to, right? So we are going to apply the same thing in here. So now let's come to analyze again. Then now we are coming to compare means. That's what we are coming to do, compare means. Compare means, and we come to sample statistics. One sample t-test. Right, so you can see that only the numerical values will show up here. So first one, we are comparing the mean, the population mean of age. So let's this thing be on age, click on it and click here to bring it in here, right? Then remember, we've estimated that, we've said that the population mean is 23, right? So you type that 23 in this box here. If it is 21, you type that one. So any of the distance you are going to type is 23. So let me put something. All right. So confidence level is confidence interval is 95. Since it's 95, then we have 0.05 or 5% alpha, right? So when it is 90, we have 0.10 alpha. When it's 95, we have 0.5. Because the total of everything is 100. And if you are having 95% significance of confidence interval, then it means that you have 5% chance of error. So that one will be our alpha. So okay. Now our t-test has been brought down here. Our hypothesis has been brought down here, right? And this is what we are having right now, right? Remember that, let's go through this one by one. And here is the sample size. Remember, they are 30. Let's go into our data. Then you realize that the sample size is 30. Remember, it's up to 30. So the sample size is 30. The mean is 21, which is the sample mean is 21. The sample standard deviation is 1.287. And then the standard error mean is 0.235. Right? So he made mention that he can choose to clean 0.235 and then tell us to compute. Right? Remember, the full this thing is x bar minus u all over s over root n, right? So x bar, which is the sample mean minus the population mean, is what we term as the mean difference. So here in this case, the sample mean here is 21. This one minus population mean we assume to be 23 all over standard deviation is here. S is standard deviation, sample standard deviation all over root of n is this 30. Right. And this, when you put it on the calculator, you are going to get this t. So he can leave this for us, this for us, this for us, and then he will tell us to compute for t. Or he can also leave, he said he can clean here and then tell us to compute for this. So when we want to compute for this, it is only this part, s over the root of n, this part, right? It's only this part. So it is the standard deviation. So here, sorry, here is 1.3. What did I do? This is the standard deviation, which is 1.287. Right. So if they tell us to compute for the standard error, then standard error will be 1.287 all over root of 30. This is standard error. Right. This is standard error. And then and we are told to compute for standard deviation, it will take a very long time. It will take a very, very long time. And then the mean is basically the total sum of the distance, which is not in here, but when you go to Excel, you will see the sum. So the sum over the number of samples, right, which is 30, will give us the 21. So in Excel, the sum is 630. It's 630. Like 630. So this is 630 all over 30 will give us that. You get it? So that's basically it up to this point. Right. Now let's move on to some other interesting part. Some other interesting part is this degree of freedom. We can be asked to compute this degree of freedom. If we want to compute this degree of freedom, because it is only one sample, we are using one population sample or something like that. It is n minus 1. That's why it is 30 minus 1. It is equal to 20. That's why it is there. So this 30 minus 120, and that's why we are getting this. And then this significant figure being two-tailed is the p-value. But wait, let me talk about the mean difference first. The mean difference is basically the difference between the population mean and then the sample mean. So it is x bar, it is the sample mean minus the population mean. That is the one giving us the mean difference. So it is 21 minus 23. That's why we are getting negative 2.000. Get it? So now let's talk about the significance. This is the p-value, right? This is the p-value. This is when we're going to trace this on the normal distribution table. This is what we are getting, 0.001, right? So what we are going to do is that we are going to compare this to our alpha. To see whether we are rejecting or accepting this hypothesis, right? So what we are going to do now is that, remember, they've written here two-tailed here. So meaning that alpha will be divided by 2. Remember, alpha is 5% since we have 95% confidence. The room of making an error is 5%. So that's what we are going to do here. So alpha is 5%. So since it is two-tailed, it will be 5% divided by 2. So 0.05 divided by 2, which will give us 0.025. Remember, when you solve for alpha, when you solve for p and it is less than alpha, right? When it is less than alpha, we fail to reject, which is fail. We write fail when it is exam. And then when it is greater than this, we do what? We reject. So it is either fail or reject. That is going to be our answers index. So, for example, for this one, when we draw this, then we draw our bell shape. Right, the bell. With the bell, we blue though. This is bread. And so since this is two tail, here and here is negative. Wait. Oh, I'm coming. Let me check and draw it too. So now here will be your p value. Okay, no, let me bring alpha here. Let me bring alpha here. So 0.025. And then here is negative, so here will be positive 0.025, right? So this is it in here. So now our alpha now is 0.0001, 0.001, which is less than 0.025. So it is around here, 0.001, because it is less than alpha and it is not in between negatives too. So remember, this shaded area is rejection zone. Rejection zone. And then this area is fail to rejection, fail to reject zone. Right? So this is fail to reject zone 001. Right? So since this is here, since the p-value is less than alpha, then wait, I didn't draw this thing well. Let me draw it well, please. Sorry for the confusion. I don't want to. Okay. So now in the slides, we're rather comparing p value to the alpha. So now let's do this. So p value is 0. Here is negative 0.001. Here is 0.001. P value is here. We use alpha to check here. So now, if p value is less than the alpha, right, then Why am I getting confused here? Because yes, in comparison, if p value is less than alpha, we are rejecting. Yes. So now alpha is here. It is 0.025. Since it is alpha, here will be negative 0. So we had positive, so we don't really need to bring. I get it. I get a confusion. I was just confused. And so one confusion. So now because here is the rejection zone, right? So if the alpha falls within the rejection zone, we are rejecting the HO. That's the mean distance is 23. You get it? So now this is it. Just take this, put this down, right? Put this down. When the p-value is less than the alpha, right? Which is when this one, when the p-value is less than the alpha, is alpha. I'm mentioning it. Why? It's less than the alpha. Then we are rejecting the null hypothesis, right? So we are writing reject in there. Then we are rejecting equal to reject. So this is what we are supposed to write. But when p-value is greater than alpha, then we fail to reject. So this is what we are writing, fail to reject. So this is what we are supposed to write in the answer part. So we fail to reject. Do you get it? I hope this is not too confusing like that. So keep this in mind. When p-value, which is this is the p-value, the significance, this one is the p-value. When it is less than the alpha, which is 5% divided by 2, right, which is 0.025. If the p-value is less than it, then we are rejecting. But when the p-value is greater than it, then we fail to reject the null hypothesis. That's basically it up to this point. I hope there's no question. If there's any question, you can come into my DM and then I'll be glad to clarify it for you. So let's move on. So basically, we can also do the same thing. We can do the same thing for the other one. I think you can do it, right? When we come to on this, we did it for age. You can also do it for monthly allowance because you can't do it for World Cup and then gender because they are numeric. They are not sorry, they are not numeric. You get it? You don't have skills, right? So we can also do the same thing for. So we come to compare. We come to analyze, compare means, and then we come to one sample t-test. We have age there already. Let's bring age back, and let's put monthly allowance in there. Then let's see whether the options are selected already. Everything here was selected. Okay. it will process. Okay, it has processed already, and it has given us. And here, our sample size is still 30. Our mean is still here. Standard deviation is still here. Standard error, which is the standard deviation over the root of the sample size, it's here. We have our T statistics, degree of freedom, which you already know is 30 minus 1. This is our significance figures, 0.001 is so still we are what rejecting. And then we have the mean difference, which is okay. Sorry. I didn't take this into consideration. So compare means one sample. Here it is not 3. Let's let it be like, let's say in average it is 900. That would rather make sense, right? So this is it. 900. Yeah, this is what we are having, and this is our T test now. You go for it. So now you see that the p-value has changed. This p-value has changed to 158. This 158 is greater than 0.02, right? So now we fail to reject the null. So for this one, for example, we will fail to reject. Right? So in the question, for example, if they want us to compute anything, they will assume the population mean for us, but the sample mean will be here. This is sample mean. Population mean will be given to us, and this is the sample mean, right? So basically, this is up to this point, right? So now let's go and then do for this. Where is the PowerPoint? Wow, I thought there was a PowerPoint. Hey. Yeah, the PowerPoint is there, fine. All right. So now let's go here. So now we are coming to do a 2 sample test. Right? We are done with 1 sample test. I come to do 2 sample tests. And this is the information I'm coming to use. So 2 sample tests. We are comparing the study of SMEs, small enterprises. We are coming to compare their performance in Ghana, right? And we are coming to check in the case of family-based SMEs and the partnership-based SMEs. That's what we are coming to do. And we are coming to compare their performance with their sales, right? We are coming to use their sales. So this is for the family year 1, year 2, and then for the partner. So this is what we are coming to use. So we are coming to do a 2 sample test, right? Remember first we did a 1 sample. Here we are coming to do a 2 sample. So follow me clearly. Let's go. So what did you do? So we come here. Now we've only added this, so we have to create for the SMEs, right? I am to create for the SMEs. What did you do? So SM is as the name. Remember, it is not numeric, so string. Then here is type of SME. So let's use 1 for family-based SME. And then let's use 2 for let's use 2 for this thing, partnership based. Let's add. Okay. Remember, this is nominal because it is name. And now sales. Okay, performance. So performance is numeric because it's cash, it's money. So sales, we are using the sales volume. Right. So here is so none, and then here is Q. Right. So we have them here. We have the SMEs, and then we have everything here. Right, the SMEs and we have. So now what we are going to do is we are going to import everything in here. Right. So what do I do? I'm a bit confused here. I'm not sure I'm that confused. So let's family base is 1, partnership is okay. So I'll copy. This is for this thing. This is for family. And we indicated family as 1. So let's type it the 1 enter 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 1 enter. You get it? So because it is family based, we use 1. We indicated 1. That's why 1. When you press 1 and then you click on enter on your keyboard, it will come 1 and enter 1 and enter 1 and enter. Right. So now let's come and then copy for the partnership base to Control plus C, and then let's paste Control plus V. So now I'm coming to use 2 enter 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 2. Right. So currently we've filled up this. Right. We've filled up this. Right. So now let's go to analyze. Because we are coming to use 2. I don't know whether this will pick up, but if it doesn't pick up, then we will need to clear some of the sample size. Because since there is some space here, it's either we fill it up ourselves or we clear these ones out, like this one. But let's see, I'm coming. If it works, we won't clear. But if it works, if it doesn't work, we'll clear. So we come to compare means. And then because now we are testing between 2 distance, we are coming to independent sample t-test, right? Independent sample t-test. Come there. And then now it will be SMEs. So for the SMEs, we are having 2 types. We are having family based and then sales volume. So first we click the sales volume and we send it to come to the top here. Right. Now we click the type of SME, bring it here. So remember, there is question mark showing up here, so meaning that it is not defined. just have to define it to the same thing. 1, we know 1 is equal to family base. So 1 at the top, 2 at the down. Continue. Right. Let's check whether everything has been here. So here it is 95%, and then everything. And then remember that when it comes to two-test statistics, two population, sorry, this is how it is, right? Remember the formula is, will I even remember? I think so. It's X, the sample mean of the first thing, minus X bar 2, right? Minus U1 and then U2, something like that. Did I write it? Hey, Akwana Anchuro. I said make U1 minus U2. No, it is not X squared. I'm not sure it is X squared. X squared. I'll check in the slide to compare. So X bar 2, right? So minus U1. Let me put this. Let's be able to write it here. So X, wow, X1, the sample mean of the sample mean 1 and a sample mean 2, all minus the population mean 1, population mean 2, all over the standard error, which here is the standard error, S over N plus S over N. I think they are all squared or so, something like that. Let me check in the slide. Forgotten. All right, so it is rather like this. It is similar, but it's like this. Me and Pan, I'm really fear David. So this is a mistake I did. The square is not supposed to be here, but it is supposed to be here. Yes. Right, the standard deviation should be squared, and then over N1, N2. So this is the formula. And in two-test statistics, we assume that through hypothesis for two population, we assume that U1 minus U2 is always equal to 0. Sometimes they can give you, and they will ask you that compute U1 minus U2. It is always 0, right? Because they won't give you anything. They will be like compute U1 minus U2. It is always 0. Keep it in mind. So now we will only be dealing with the difference between the sample mean of population, the sample mean 1 and the sample mean 2. So this is the formula. So now let's continue and then see whether our destiny will play out. So now we are done with everything. We've defined everything and everything. Let's click OK. Okay, so it worked. It worked. So remember, our sample that we selected was 10 from each, because when you check, it was 10 from the family base and then 10 from partnership, right? So the same thing is in here. 10, that's why we are seeing 10, 10. And then this is the mean of the first one. Then this is the mean of the second one, right? This is their standard deviations. And then this is their standard errors, right? So this is their mean difference, and then this is their significance distance. So it's still the same, right? So now we can also be asked to do the same. We can be asked to compute the degree of freedom. Remember, degree of freedom is what? N minus 1, right? But here it is 2. 2 distance. So it is now, it will be N1 plus N2 minus 2, because we're selecting from 2 populations. Get it? That's why degree of freedom here is 18. So 10 plus 10, because this time we selected only 10 samples. Which is also 18. The mean difference is the same thing. And then the standard error is the same thing. So the standard error here is this one. If you are asked to compute the standard error is the root of standard deviation 1 squared over N1 plus standard deviation 2, the second standard deviation squared over N2. This is the standard error if you are asked to compute the standard error. And then the sample size, we know we selected only 20, that's why it is 10, 10. And the mean, and then now this is the p-value. Right, so this is the p-value. This is the t-test. Remember, this is the t-test, right? This is the p-value. So now alpha is what? 0.025, because we are dividing the 5% by 2, right? So since we are looking at this clearly, we can see that alpha is greater than the p-value. So we are doing what? We are rejecting the null hypothesis that let's say if we are comparing the first one, the family base, to performing better than the partnership base, right? Since p-value is less than the alpha, we are rejecting that claim that it is true. So we reject. So remember, we are writing only reject. And then when we are accepting, we write fail, right? So far, this is what we've covered so far under this. And I think it is well understood. I pray so. If only it is not, you can come into my DM. I'm always available. Yeah. So I'll upload this very soon, and then you get your share and copy of this. Thank you very much for watching this video. Kindly don't forget to like, subscribe, and then get updates on almost anything that I get answered. All right. Thank you very much for your time. Goodbye. Sorry, your name is Fearfully Ugly. Let me check whether I did everything. Okay. Descriptive, I've done it. Let's see whether I've done everything. Okay. So, all right. So, I think next week we'll do something and then we said it's online. So we will see what we can do. All right. So, all right. So basically, all right. So see you. Bye.